Hi viewers and students, the topic is ONEWAY ANOVA, which is the topic of research methodology and statistics. This is the part of testing of hypothesis. Here is the problem. Set up an analysis of variance table for the following per acre production of data for 3 varieties of wheat, each grown on 4 plots, and state if the variety difference are significant. So here we have 3 varieties of wheat, and 4 plots. So here we are studying the effect of variety of wheat on the land. So here the question is, state if the variety difference is significant or not. So this is the given problem. Plots of land 1, 2, 3, 4 per acre production, variety of wheat A, B, C. So in plot 1, when we use the variety of wheat, the yield is 6. If we use the variety of wheat B on the plot 1, the yield is 5. When we use the variety of wheat C on plot 1, the yield is 5. Likewise, all these entries. Now, to solve this problem, we will first see the procedure. In step 1, first obtain the mean of each sample. So here A, this is one, B is another sample, and C is another sample. Now mean of the first sample is x1 bar. We know the formula for mean is sigma x by n. So sum of all these values divided by number of values, 6 plus 7 plus 3 plus 8 by 4 values we have, so 4. It is 24 by 4, 6. Now x2 bar is sum of all these values by 4. It is 20 by 4, 5. x3 bar is sum of all these values divided by 4. 16 by 4 is 4. In this step 2, we will find mean of the sample means. Here x1 bar is 6, x2 bar is 5, x3 bar is 4. Now we will find mean of all these means. So x bar is mean of sample means. This is x1 bar plus x2 bar plus x3 bar by k. So 6 plus 5 plus 4 divided by 3 means are there, so 3, which is equal to 5. This is step 2. Now step 3. Obtain sum of the squares between the samples. It is called as SS between. So the formula is n1 into x1 bar minus x bar whole square plus n2 into x2 bar minus x bar whole square plus n3 of x3 minus x bar whole square. Now here n1 is 4, n2 is 4, n3 is 4. Because we have 4 samples, so n1, n2, n3 always 4. And x1 bar is 6 here, x2 bar is 5, x3 bar is 4. So x1 bar is 6 minus x bar value is 5. So 6 minus 5 whole square plus 4 into x2 bar is 5, 5 minus 5 whole square plus n3 is 4, x3 bar is 4 minus 5 whole square. So this is 4 plus 0 plus 4, which is 8. Now in step 4, we will find SS within the samples. So this is the formula to find out SS within. So it is sigma x1i minus x1 bar whole square plus sigma x2i minus x2 bar whole square plus sigma x3I minus x3 bar whole square. So sigma x1I minus x1 bar means, if you take I is equal to 1, this is x11. If we take I is equal to 2, this is x12. So in simpler way, just take all the first sample values minus x1 bar. So x1 bar is 6, 6 minus 6, 7 minus 6, 3 minus 6, 8 minus 6. 6 minus 6, 7 minus 6, 3 minus 6, 8 minus 6 with whole squares. Plus next one, 5 minus 5, 5 minus 5, 3 minus 5, 7 minus 5. Plus third one, 5 minus 4, 4 minus 4, 3 minus 4, 4 minus 4. So its value is 24. Now in step 5, we will find SS total variance. The value is sigma xij minus x bar bar whole square. Xij is all the entries of the given table. So x bar bar value is 5. So 6 minus 5. Subtract this x bar bar value from all the values of this table. So 6 minus 5, 7 minus 5, 3 minus 5, 8 minus 5, plus 5 minus 5 from all the values. It is 32. Now in step 6, SS for total. SS total is SS between plus SS within. So this is SS between is 8, SS within is 24. So it is 8 plus 24, 32. Now one-way ANOVA table. This is one-way ANOVA table. So in this table we have sources of variations, SS, DF, MS and F ratio and F limit at 5% level. In this row, between the sample, within the sample and total. So SS between the sample, SS between the sample is 8. SS between the sample is 8. SS within the sample, SS within the sample is 24. So it is 24. Total is equal to 32. Now degree of freedom is 3 minus 1. 3 varieties of seeds, no? 3 minus 1 is 2. And here within the samples we have 12 entries. So 12 minus 3, 9. So total is equal to 12 minus 1. It is 11. Now mean squares. Mean squares between the samples is 8 by 2, that is 4, and mean squares within the sample is 24 by 9, which is equal to 2.67. Now for 4 by 2.67, for 4 and 2.67, the F ratio is 4 by 2.67 is 1.5. But for the degree of freedom 2 and 9, the F standard table value is 4.26. This is from the standard table of F. And here F ratio calculated value is 1.5. So what is our conclusion? F calculated value is 1.5. F tabulated value is 4.26. How can we get this tabulated value? We have F standard table in the internet or backside of your statistics textbook. So from that F table at 2 and 9, degree of freedom 2 and 9, the value is 4.26. So here F calculated value is less than F tabulated value. 1.5 is less than 4.26. 26. So if this is the case, in this case f calculated value is less than f tabulated value, we will accept the null hypothesis. What is the null hypothesis? There is no significant difference in the sample means when we use different varieties of weeds. So the analysis supports the null hypothesis of no difference in sample means. So by using a one-way ANOVA technique, we can find the effect of one factor on one plot.